Okay, guys, we're getting down there. You got this week of assignments, and then next week, and then after that, your exam week, and then I think we're done. So keep up the good work and keep showing your steps out clearly. It makes it very easy for me to see what you're doing and see that you're getting it. Okay, so here we go. This is lesson. We're on to lesson number 11. And we're talking about arc length. Arc length. So still dealing with circles. And there's going to be a formula here. So the formula goes like this. First off, you're going to have a circle always. Just to make it consistent, I always made the center B on all these circles. You're going to have arc AC, which goes around like this. And so it looks like this, and then this is the arc. I'll darken it. So arc AC, we're finding the length of arc AC. So here's the formula. It equals the angle, so the measure of the angle B, which is the central angle, divided by 360, times the circumference. Okay, so that's a general idea. See if I can get this thing to focus better here. Here we go. Okay, so here's another way to look at it. Angle B over 360. Remember, circumference is just pi times d. So some problems you just plug in the circumference. Sometimes you got to plug into this. So it's going to be one of these two formulas that you'll use on all these problems, which is really the same formula. All right, so here we go, 3 examples. Number 1, let's say it's a 90-degree arc. So let's say draw a circle B, draw arc AC, which is 90 degrees. That would be the setup on this one. So you should draw it out like this. This is the central angle that you're talking about right there. And let's just say they tell you the circumference is 80. Okay, that'd be a simple example. So let's look at the formula, and we want to find arc AC. So what is arc AC? Question mark. Okay, so let's just look at the formula quick. Angle B over 360 times the circumference, which in this case we're talking 90 over 360 times 80. Okay. What you're going to want to do is reduce this fraction down. It'll make it a lot easier. So reduce 90 over 360. It's actually 1/4 times 80 over 1. So when you multiply across 80 over 4, it's just 20. Which hopefully makes sense. You know, if it's 80 all the way around, this piece here is just going to be 20. You know, it's 1/4 of the way around. Okay, that's a real simple example. This one will be a little tougher. What if they tell you central angle is 120? So say circle B, it'll say arc AC has a central angle of 120 degrees. And then it will also tell you something like a radius. Let's say the radius is 9 centimeters. All right. So that's all the given information. It'll say how long is arc AC. All right, use the formula. Angle over 360. In this case, I'm going to do times pi d because I can figure out the d. Okay, so 120 over 360 times pi times d is 18, right? So 18 pi is the circumference. Reduce this fraction. Most of the time, these fractions reduce down to pretty nice stuff for the problems I give you. So this is actually just 1/3 times 18 pi, or pi times 18 over 1. Okay, so you could reduce here before, or you could just multiply across 18 pi over 3, and then make sure you reduce at some point here. So 18 divided by 3 is 6, right? So the answer is just 6 pi as in terms of pi, if it says, you know, and then it might say give it as a decimal, is 18.84 centimeters. Okay, oops, So I just plugged into the formula and then just got to solve this out. Okay, the third one here is a little tougher. Make sure you do keep watching here so you can get this one. Why the color is so bad. There's a little better. Okay, this one's going to say this. It's going to say arc AC is 8 pi centimeters long. And it's going to say the diameter of the circle is 12. And it will say how big is angle B. So we really don't know. I mean, you could kind of draw this out, but we really don't know how big the angle is, so it's kind of hard to draw it out. But I could say, well, 8 pi is here. It's how long this is. We're trying to figure out this angle here. So I'm actually going to call that x, actually. Okay? But I don't think you'll have to draw the picture on that one because we really don't even know what it looks like. But let's just use the formula. Arc AC is the angle over 360. I'm going to do the pi d here because I do know what d is. We're trying to figure out angle B. All right, so plug everything in. 8 pi goes here. We don't know angle B. That's the x. We do know the d was given. That's 12. Okay, so we're dealing with this. We got to solve this whole thing out for x. You got different options. The easiest thing I can see is just times each side by 360 to cancel that out. Okay, because that actually will cancel that. So 8 times 360, 2880. Pi, don't lose the pi there, equals x times, is 12 pi, right? Because now I could just cancel out this 12 pi, divide each side by 12 pi. In other words, the pi's cancel there. So 2880 divided by 12. The pi's cancel. You're just left with 240. Okay? So if you want to see the picture, 240, that's like, I don't know, it's almost like to here. Well, it is 180, so it's past 180, right? Maybe like here, it's this big angle here. Okay, so basically that's the hardest problem you'll see, I think, is where you got to solve for the angle. Otherwise, just always go back to this formula, plug in what you know, and then solve for the thing that you don't know.